In this video, I want to wrap up the electron transport chain by talking about oxidative phosphorylation, chemiosmosis, and ATP synthase, and sort of drawing out the complexes themselves. Now, what is oxidative phosphorylation? Just as a sort of definition, it's basically using redox reactions to power the phosphorylation of ADP into ATP. And how do we actually do that? We do it via establishing what we mentioned earlier, an electrochemical gradient, right? Specifically a pH gradient, right, with the H pluses. Now the reason it's called an electrochemical gradient is because a chemical gradient just describes the idea that if you have a membrane and you have more of one thing on one side than the other, then you have a chemical gradient. But now in the case of H pluses, right, those are protons. They're charged. They have a positive charge. So there's an electrical gradient as well, which is described as a voltage. There's a difference in charge. There's a charge separation. So that's another basically sort of aspect of the gradient itself. Now there's this idea of chemiosmosis. Chemiosmosis is basically the movement of ions down their concentration gradient through a selectively permeable membrane. So in this case, what are we thinking about for that ion? We're thinking about H pluses. ATP synthase. What is ATP synthase? It's the protein that makes ATP. So it's going to be a pretty cool protein. Okay. Now, what does the electron transport chain kind of look like? Let's kind of think about it like this. So we have, excuse me, we have 4 different protein complexes. We have complex number 1, we have complex number 2, we have complex number 3 here, and then we have complex number 4 down here. So you have 4 protein complexes, and then over here at the end, we got good old ATP synthase. So we're going to see how this electron transport chain actually works. So if this is the outer mitochondrial membrane here, and this is the inner mitochondrial membrane, then the electron transport chain is along this inner mitochondrial membrane. These are protein complexes along the membrane. So anything inside here is considered the matrix, and anything out here would be part of the intermembrane space. So if we think about this, what's happening here? So initially we said we had NADH come to complex number 1, and then it's reoxidized back into NAD+. And then complex 1 we said pumps protons, and it does. Now in biochemistry books you'll probably see that complex 1 will pump 4 protons. So for every 2 electrons you get 4 protons pumped into the intermembrane space. So these protons are building up over here in the intermembrane space. And these protons are coming from the matrix out into the intermembrane space. Now, what is this blue line I've drawn here? I've drawn a bunch of different blue lines. This kind of looks like a mess, but if you see a blue line is electron flow. So this here is electrons flowing here. These electrons are flowing here. Any blue lines you see, those are electrons flowing, which is the purpose of the electron transport chain. Any pink lines you'll see, that describes proton movement or flow. Okay. Now in this case it's against their gradient, right? So at complex 1 we know that NADH is oxidized back into NAD+, and we have proton pumping. So that's what's happening at complex number 1. And in addition, these electrons are flowing from complex 1 over to complex, actually they don't flow to complex 2, they flow over to this Q thing here, which is coenzyme Q. The complex number 2, where we turn succinate into fumarate on the matrix side of the mitochondria, or the matrix side of the inner membrane. This occurs at complex number 2, and the electrons flow to coenzyme Q. But notice that I have not drawn a pink line here going into the intermembrane space because this complex does not pump protons. Then once we have coenzyme Q, the electrons from coenzyme Q go over to complex number 3, and then to cytochrome C. And notice complex number 3 actually pumps protons as well. It pumps 4 protons as well. So we have 4 protons there being pumped into the intermembrane space. Cytochrome C then gives its electrons to cytochrome A. Cytochrome A gives it to, which is part of complex 4, which gives its electrons to oxygen, which becomes water. So we're going here from oxygen. We're starting off with 1/2